In this skill video, we're going to look at finding the inverse given an equation. Step 1 is to take a function written in function notation and rewrite it in y notation. Step 2 is to switch the position of x and y in the equation. Just as on a graph, we switch the position of the x and y coordinates. Step 3, we're going to then rearrange and isolate y. And step 4, you're going to put it back into function notation. We're going to look at two examples today, one linear and one quadratic. To find the inverse of f of x equals 1/3 x plus 1, the first step was to rewrite it in y notation. Now we want to swap the positions of x and y in our equation. In order to isolate y, we're going to start by subtracting 1 from both sides. Now we want to multiply everything by 3 to get rid of the 1/3 coefficient in front of the y. So we're going to obtain 3x minus 3 equals y. So each term has been multiplied by 3. And the last step is just to rewrite in function notation. So f inverse is 3x minus 3. We started with a line and we ended up with a line. So we don't really need to look at the domain range for this one because it's pretty straightforward. The domain would be x an element to the real numbers and the range is y as an element to the real numbers. So when we switch the x and y and the domain and range, we end up with the same thing. It's a little bit more complicated when we look at a quadratic example. Let's try and find the inverse of g of x equals x plus 1 all squared. Start by rewriting in y notation. Switch the positions of x and y in the equation. We want to isolate y. The next step would be to get rid of the squared by square rooting both sides. Remember, when you're taking a square root, you need to remember the plus and minus. So on the left side, you're left with plus minus root x, and on the right side, you ended up getting rid of the squared and you're left with y plus 1. The last step is to get y by itself by subtracting 1 from both sides. Now we're going to put it back into function notation. G inverse is plus minus root x minus 1. Let's take a look at the graph. Looking at the graph of g of x equals x plus 1 all squared, we identify this as a quadratic that has a vertex at -1, 0. It's drawn in red. The inverse graph is represented by the blue curve. We want to look at the domain range to see what's happening on both the original and the inverse graph. On the original, the domain is x an element to the real numbers, but the range is a little bit more interesting. The range for the original g is y is an element to the real numbers such that y is greater than or equal to 0. So that graph, the range is restricted because you have a parabola that's concave up, and the lowest point or the minimum value on that graph is y equals 0. When we take an inverse, we swap the domain and the range. So we would expect that the domain of the inverse should be x as an element of the real numbers, such that x is greater than or equal to 0. So if you take a look at the blue graph, you'll notice that the vertex on the original -1, 0, the x and y coordinates were swapped and we ended up with 0, -1 as our new vertex. And that now gives us a domain of x an element of the real numbers such that x is greater than or equal to 0. So the domain and the range have swapped.